Hello everyone, my name is Ajay and this is part 5B, an extension for part 5 where we have discussed about spoke-to-spoke connectivity. This is going to be the extension of that, and you might have the situation where you want to connect multi-region topologies. So your traffic from one spoke to another spoke, it goes from hub to hub. You might have this kind of the topology where you have single hub and your spokes are connecting to this hub from peering. This can be the local peering if your spoke and hub they reside in the same region. And if your spokes are residing in a different region, then you can use the global peering as well. This was explained in my previous video. You can refer to that. How these spokes to spoke going to talk to each other using this hub connectivity. Now you might have this kind of topology as well, where you want to segregate all your network in that particular region with one hub. For example, these two spokes and this hub, they are residing in one region, and these two spokes and this hub, it is residing in one region. So now you want to transfer or you want to talk to this spoke 1 to spoke 4, and all the traffic it must go from hub, then it go to another hub, and from this hub to spoke 4. And you will still have this kind of connectivity also available where you have the corporate or maybe data center and you want to connect these two hubs. So we are going to discuss how we can form this connectivity from hub 1 to hub 2 and how these spokes can talk to each other. This is going to be the lab topology which I'm going to simulate. So technically you have one spoke with the range 10.10.1/0/24, another spoke 10.21.0/24, and the third spoke 10.31.0/24. You are going to create the vNet gateway that is going to be the part of hub 1. You are going to create another vNet gateway that is going to be part of hub 2. And these hubs basically having the range /16. So hub 1 is going to have 10.100/16. Similarly, hub 2 is going to have 10.2.0.0/16. And when you are creating this vNet gateway, basically you need to carve /27 from this subnet. And then you are going to establish the vNet peering, and in this case all these peerings are going to be the local vNet peering because your spoke 1 and hub 1 they are residing in the same region. Here spoke 2, spoke 3, similarly they are going to form the vNet peering with hub 2. There is no direct peering between any of the spoke. The next step, you are going to have the vNet gateway to vNet gateway connectivity that is going to be the IPSEC, and top of the IPSEC you are going to run the eBGP for exchanging the routes. Let's understand the building blocks. What are the components needed to build this topology? So first thing you need, the vNet is going to be the hub vNet. So create one hub vNet. The second is going to be the spoke vNet. Third is going to be spoke. And then you are going to establish this pairing between this hub to spoke. After that, you are going to create the virtual network gateway, and that gateway is going to be the part of this hub. And when you create the virtual network gateway, you are going to get the public IP address associated. After that, you need to create the local gateway. This local gateway is basically going to talk about your remote subnets, and when you are going to turn on the BGP, you need to define the ASN number, peer IP address, etc., which we are going to see later on. Top of that, this virtual network on the spoke side, they are going to have the route table attached. So you need to put UDRs, and for testing purpose, you need to create the virtual machines in each spoke. Once this topology is ready, from one gateway to another gateway, you're basically going to run IPSEC plus BGP for route exchange. IPSEC basically going to form a tunnel using the public IP address, and top of that public, once your IPsec tunnel is formed, you're going to have two private IP addresses where you are going to run the BGP for the route exchange. Let's take a look on the configuration what I have. So I have these 5 vNets, hub 1, hub 2, spoke 1 to spoke 3. Spoke 1 is going to connect to hub 1, and spoke 2 and 3, they are going to connect to hub 3. That was the topology. And you can also verify the location for all these vNets. Then if you take a look, I have two virtual network gateways. So hub 1 gateway, so this gateway is going to be part of the hub 1, and the second gateway is going to be the part of hub 2. You can see the virtual network they are attached to, and the type is going to be the gateway VPN, and the location is going to be East US 2 and East US. Now let's take a look on the vNet peering. So from hub 1, I have only one peering because I have only created one spoke, which is going to be the spoke 1. We can see my peering status is connected, and this hub 1 is connected to the spoke 1, and my gateway transit is enabled. Second hub 2, that will have two peering because I have two spoke in that particular region. So spoke 2 and spoke 3, they both are connected. They are paired with the spoke 3 and spoke 2, and the gateway transit is enabled. Now let's take a look on the spoke side pairings. So from spoke 1, we can see the peering has been established to hub 1. The status is connected, disconnected with hub 1, and the gateway transit is disabled. So technically, your hub is going to act as a transit, and these spokes, they do not need to be. Similarly, for the spoke 2, we can see it is connected to hub 2, and spoke 3 is also connected to the hub 2. And everywhere you see this gateway transit is disabled. So as of now, let's consider I do not have any connectivity between hub 1 and hub 2. So this doesn't exist. So spoke 1 is connected to hub 1 with vNet peering. Similarly, spoke 2 is connected to vNet gateway in hub 2 with vNet peering. So spoke 2 and spoke 3, they can use the gateway 10.2.1.4 to route the traffic between spoke 2 and spoke 3, vice versa. Now let's test the connectivity. So from a machine which is Linux SP2, which is part of spoke 2, this machine which is Linux SP3, that is part of spoke 3, they should be able to reach other, and that's exactly what we see. So if I ping 10.30.1.4, so 1.4 is going to be the first IP which get allocated to the VM here, and similarly .4 is going to be assigned to VM which is sitting in spoke 3. They should be able to reach each other, and that's exactly what we see. If I try to ping spoke 2 machine to spoke 1, so IP is going to be 10.10.1.4. I'm not able to ping it. And the reason behind, I do not have any sort of connectivity between hub 1 to hub 2. And there's no peering, direct peering, which exists between the spokes. If you go to the two hubs what we created, so hub 1 gateway, hub 2 gateway, these are the vNet gateways. If you take a look on the BGP configuration, that is how it looks like. So you need to select one of the gateway, go to the configuration, and configuration, you can see this is the SQ type. My active mode is disabled. I'm not using the private IP address. My BGP should be enabled, and the moment you enable it, you need to assign the ASN number. These are going to be the private ASN numbers. So on gateway 1, I have given 65512. Similarly, on gateway 2, I have given 65516. And the reason behind we wanted to establish the eBGP connection here. This is going to be the BGP peer IP address. So on gateway 1 is you see 1.254, on the gateway 2 you see 10.2.1.254. If you want to use a PIPA IP address, you can define those IP addresses, but here I wanted to establish connectivity on these two IP addresses, so I leave it blank. Let's take a look on gateway connections. So from hub 1 to hub 2, since we are going to have the IPSEC connectivity, so you need to go to hub 1 and then go to the connections, and from connections you need to add a connection, and the type of connection is going to be IPSEC. So what do we see here? The name is H12. It means it's a hub 1 to 2. Status is connected, type is IPsec, and peer is local hub. Similarly, if I go to gateway 2, I see H21. Since this is a connection from hub 2 to 1, status is connected, type is IPsec, and peer is hub 2. Now let's take a look how to add the connections. If you go to the gateway and under the configuration, there is an add option, add connections. So this is the screenshot for hub 2 gateway. It is going to ask a name for the connection, the type of connection is a vNet to vNet, IPsec, and express route. We were configuring site to site. So select site to site. You need to put the shared key, and this shared key you are going to use the same shared key when you are creating the connection from other side as well. Enable BGP, and you have an option whether you want to go for IK1 or IK2. In my case, this is the default one. While creating those connections, the one requirement is to put or configure the local network gateway. So in my case, you can see two. When we were configuring a connection from hub site 1, you need to use this one, and another site you need to use this one. So what is the configuration it is going to carry? So while creating it, you need to go to the configuration, and configuration you need to put the IP address. IP address, this is the IP address of remote, and that is being used for creating the IPsec connection. You see the address space also here. If you're not running this BGP section, then you need to use a typical IPsec connection where you need to mention the encryption domain, so you can define your number of domains. In my case, since I'm going to create a BGP connection on top of the IPsec, I don't need to mention it. Those subnets will be learned automatically. So I leave it blank and go to the BGP configuration. Under the BGP, you need to define the remote. So remote ASN number is 65516, and my BGP peer IP address is going to be 10.2.1.254. That is the configuration which will be on the hub 1. Similarly, you need to configure hub 2, and you need to put all these IP addresses over there. So on the other side, local hub 2, you're going to put the remote IP address, ASN number, and BGP peer IP addresses. That was the only requirement to form the BGP on top of the IPsec. Now, in a gateway, you go to the BGP peers. There you can see the BGP peer. I'm part of hub 1. So remote is going to be hub 2, and this IP belongs to hub 2. So I can see there's a BGP peering got established from 10.1.1.254, that is a local address. Peer is 10.2.1.254, that is a remote. My ASN number 65516, status is connected. This is the duration, and the number of routes received 3, and these are the BGP messages being exchanged. Learned route, you can see self-originated routes and the routes which is learned from the remote. So remote is going to be these, which is coming with the origin eBGP. Since we are on the hub 1 side, hub 2 side had spoke 2, spoke 3. So this is spoke 3, this is spoke 2, and this is hub itself. Similarly, on the gateway 2 side, we see two routes being learned. One is going to be the spoke 1 and second is going to be the hub 1 itself. Now my BGP peering has been established, routes has been exchanged. If I test the connectivity now, it should work, and that's what we see on the screen. So from spoke 1, I'm able to ping spoke 2, and from there I'm able to ping spoke 3. It means I have a full reachability now. Let's talk about the last piece, which is going to be the UDR. So you need to keep in mind, you need to put the UDRs in all the spoke subnets. So I created three UDRs, UDR1, UDR2, UDR3. And UDR1, if you see, I do not have any route. The reason behind UDR1 or spoke 1 UDR, it is connected to the hub, and I had no second spoke in that region. So this UDR is only required. You need to put some routes if you want to do some traffic to be routed within that region. For example, if this is my hub, this is my spoke, this is my spoke. If I need to route traffic between these, so my traffic has to go from here and it should come here. So here is going to be the gateway device basically. To route this traffic, you need to put those routes manually. So this is a hub site 1, and I had only one spoke. If I don't have this one, I probably do not need any route. On another side, where you had hub 2, I had two spoke 2, spoke 3. And we have tested the connectivity. So to do the routing between these two spoke through this gateway, I need to tell S2, if you want to reach to S3, this is going to be the next hop. But the routes which is being received here from BGP, so you don't need to configure a routing table to reach spoke 2 to spoke 1. That will be done automatically. So whatever the routes is being learned from the BGP, they will be installed directly on those UDRs, and those will be effective for these hosts as well. Let's examine the second UDR. So this is a UDR SP2 UDR, which is applied to SP2. There I see I have a route for how to reach spoke 3. Similarly, the third UDR, SP3, it will have a route how to reach SP2. I do not have any other routes installed manually. Now, in SP2 UDR, if you take a look on the effective routes, I had no manual routes installed, but I'm getting all these routes. Those are learned from BGP. One very important step which we should not miss. When you go to the UDR, go to the configuration and make sure you propagate gateway routes, and that should be selected as yes. Thank you for watching, and I will see you in the next video.